there's quite a lot of researchers in the community who are saying, hey, maybe my particular approach to aligning AI, maybe that approach will work. And that will be the golden ticket and will get us out there. But let's just go to this argument. Maybe we can build the ultimate machine, and this ultimate machine might be able to finally rectify everything because it's intelligent enough. Then we're dealing with additional problems that I call substrate needs convergence. You've got this population of components that are interacting with each other in a way that are at least able to maintain and reproduce their own components. And that's a setup for evolutionary selection. We can't just chase after these AI companies and keep trying to interpret and align every new model they come up with. This is a way that we can actually stand up with pride and take action and act with integrity to make sure that increasing harms are going to be stopped and that we prevent the worst kind of extinction risk happening, not just to humanity, but basically we're talking about total ecosystem destruction. Like, this is serious business. And I think we need to be able to be looking at this in an open enough way to look at like, hey, what are the different ways we could approach this?
In the 1950s, Alan Turing said, "It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should expect the machines to take control." This is why many AI safety researchers focus not on control, but on alignment. That is, building AI in such a way that what it wants is compatible with what we want. What it takes to succeed in such a task is the subject of this channel. But what if the problem is solved and it doesn't hold up? What if alignment is not enough? My guest today on Guardians of Alignment is Remmelt, a co-organizer of AI Safety Camp, an organization that connects aspiring with veteran alignment researchers on technical projects as well as initiatives to prevent the development of uncontrollable AI. He believes in a theory called Substrate Needs Convergence, which is that, regardless of its initial engineered values, AI will eventually succumb to evolutionary pressures to expand and, as a consequence, make the Earth uninhabitable for biological life.
Hey, I'm Remmelt. I'm a co-organizer of AI Safety Camp, where I lead the area Do Not Build Uncontrollable AI, running that with Linda Linsefors. We've been running this research program for 5 years now, since 2018.
And what initially got you interested in AI safety?
Yeah, I actually got into it from the effective altruism end. So there was this meetup group in the Netherlands, and people were like, hey, you can have a multiplier this way by starting another kind of EA group. Or wait, there's this extinction risk thing that where you might have a tiny little like difference in terms of reducing the risk, which to me sounded very surprising. And also just like not very appealing at the time, because like, oh, here's this tiny percentage difference you can make in a very kind of abstract and hypothetical risk. But from that perspective, I was also thinking, well, many other people are also going to relate with it that way. So I had a bit of a contrarian streak as like, oh, maybe that's actually then the better thing to focus on. A lot has actually changed since then. I'm not actually connected with effective altruism anymore.
For those who are not familiar, could you describe very quickly what effective altruism is?
The notion of effective altruism is doing the most good. Basically, the idea is there's so many things you could do with your money and your time. You might be able to do more good than other ways, which I think overall is a good way of thinking about it. I think what effective altruism is missing as part of its construct is what I would call effective empowerment. So there's a lot of focus on the consequences and not enough focus on choice making, of enabling people to make choices based on their values and connections with other people. So that's where I started as an EA organizer, building the community there before I got more critical. At some point, I met Linda Linsefors, who's my co-organizer for the current edition at Effective Altruism Global. And she was a researcher already at the time. She was working on AI safety, but felt that doing it alone was actually not very motivating. And it wasn't helping her as much in doing research. So what she wanted to do was create a place together to collaborate with other people, co-work, have those interesting kind of whiteboard conversations. So that's how AI Safety Camp actually started, from Linda thinking like, hey, I want something like this for myself, and I think other people might want this too. And I talked with her. I thought like, yes, I'll help with this. I'll get this program started with you. And other people came in immediately in the first week. We got an organizer team of 5 people. We said something about the pent-up demand here. The fact that 5 people were just like, yes, I'm going to help organize this, says something about the fact that this was needed. People were actually wanting to have a format like this. So originally that was going to be just like a small test format with, I don't know, like 6 people hanging around in the Gran Canarias, which is an island, Spanish island. And it turned out that more people were interested. We accepted at least 12 people at the time. It became this really dynamic event where we just spent 10 days in some hostel in Gran Canaria with creaky beds and not very soundproof walls, like having these magic whiteboard charts, people taking notes, people sharing ideas, going on morning yoga sessions together. So that was awesome. And that was the start of AI Safety Camp. Since then, COVID happened. So we had to actually pivot to something that was going to work in COVID. And that's how the virtual edition happened. So that's what we now actually are running, the virtual edition of AI Safety Camp. And we have around 130 participants joining this camp, not counting the research leads who've started these projects that these participants are joining. And that's where we are up to now. People have joined the projects. We had our opening weekend and people are off and running.
Actually, I can give a personal vouch for this. I'm a part of the AI safety camp, building a Grid Worlds level editor for Jaap's Teitzig's group on Satisficers. He was a guest on the show earlier. It's been quite invigorating to kind of have that group feedback and dynamic, so I'm not just like working on something in isolation and have no idea whether it's going to be useful to anyone.
Yeah, it's great to have that as a virtual format as well for people who can't like travel all the way to a Spanish islands. And to be able to do that part-time next to the job. Yeah, so that's the idea of AI Safety Camp. And I think this the way that we're offering people who are maybe somewhat outside the traditional hubs, the Bay Area and Oxford, a way to actually start collaborating with each other. There is these 2 areas, which is do not build uncontrollable AI, which is the area I'm overseeing. So the projects in that area run by research leads. And there's the other everything else bucket by Linda Linsfors, who's maybe more open-minded and just kind of open to lots of diverse approaches. So we've got those 2 areas for AI Safety Camp. And there's actually a reason why we split that up that way, which had to do with me coming around to a very different set of views around AI safety.
I would be interested in moving on to some of your personal views on AI safety. In particular, you wrote a essay that's posted on Less Wrong, the control problem, Unsolved or Unsolvable. Say a little bit more about your thoughts here.
Yeah, so let me talk about this from where we seem to be right now, according to many researchers. Elia Zakowski posted this post called AGI Ruin, a list of lethalities, outlining some common sense, well-known things that we haven't been able to solve yet. On one hand, there's quite a lot of researchers in the community who are saying, hey, maybe my particular approach to aligning AI, basically controlling AI in line with values to stay safe, maybe that approach will work. And that will be the golden ticket and will get us out there. But on the other hand, usually what happens in this community, and there's a bunch of other researchers have, actually, here are all the things that are wrong with your approach or that you haven't solved yet. And by the way, you're actually only focused on a sub-problem of this larger kind of overarching problem that would actually have to be solved in order to control AGI to stay safe. From that perspective, if we actually start to look at all of the different sub-problems people have identified, all the new things that have come up over time, like, oh shit, that's a thing as well. Like, for example, inner outer alignment was an example of this, as something that hadn't really been considered as much until a researcher who actually was at AI Safety Camp before wrote a paper about that with myriad people. And so there's many examples of like, oh yeah, shit, side effects. Actually, there was an AI Safety Camp project specifically about this. Actually, there is a problem with chaotic dynamics and things like that. And like, it doesn't seem like we've actually adequately addressed that. So you've noticed over time as a community, we've cataloged many problems. And I think if we're reasonable about this, we can say that most of these problems have not been solved or like at best be partially solved, but with a lot of kind of assumptions with it. Like, okay, under these assumptions, maybe this will be a way of solving this sub-problem. So basically what we've done over time is we've noticed more sub-problems, more ways that we haven't yet been able to solve these overall problems. Our sense of the complexity has expanded. but we haven't actually been able to, at the same time, find some kind of elegant solutions that address a bunch of these across the board, where there's high confidence based on many perspectives, looking at many possibly unsound assumptions, that there are actually solutions that are going to work across the board. Starting from that perspective, I actually write that post. It's like, hey, like we've been at this for 20 years, basically since Elias Lukowski started. It seems like we just identified a lot more problems over time, a lot more sub-problems, and that we haven't made much traction on that overall. There's some cool ideas that come up, but then there's also ways that people push back. Mechanistic interpretability right now is something that's cool, but then it's also very easy to identify all the weaknesses. I actually just posted another conversation of myself with a friend saying, oh, here are all the ways that something like mechanistic interpretability is actually really limited in terms of being able to control AGI to stay safe, and actually just would be insufficient, even as part of a larger alignment setup.
The basic dynamic you're described sounds like the common path that pretty much any complex challenge takes. You start looking at it, it gets bigger and bigger and bigger as you understand the problem better and better. But that's actually a necessary step towards eventually starting to solve things, converge things back down. And also part of that convergence is recognizing that maybe some of the sub-problems actually weren't really problems. I think a lot of the AI optimists like Nora Belrose and Quentin Pope say most of the central things don't even matter. Or people start to find ways that these certain ideas are similar to each other.
Yeah, that's a fair point. So maybe so that's an alternative view. So perhaps we've just become better at like uncovering all of this in terms of granular detail, and over time we'll notice that what we thought were a bunch of distinct sub-problems are kind of actually a similar problem, and everything kind of merges up. And then maybe with that, suddenly we find some elegant solution that covers this thing where there's this potentially extremely dangerous technologies that really needs to be constrained, and we found some way to constrain it. So that could be another interpretation of what's happening. So the post is titled "The Control Problem: Unsolved or Unsolvable." So this is basically the question I want people to start up with. It's like, hey, what's happening here? Is it just like it just takes a bunch of time to solve this? Maybe too much time. So even if it was actually in principle, quote unquote, solvable, we would still not be able to solve it on time, given how fast these companies are speeding up. Hence, we should actually start working on getting these companies to not build potentially uncontrollable AI.
Yeah, that would be Eliezer's view. I would probably summarize it as like, yes, it's going to converge eventually, but it's just too slow versus how fast AI is developing. And so even though there's a solution, we're not going to get there. But I understand that you go actually further than that.
Yeah, I go further than that. I can't do it full justice here, but if you properly read through the posts, the way I would summarize this is there's actually basically two parts of this argument that interact with each other. On one side, there's this notion of fundamental controllability limits. In order for something like AGI, which I define more precisely in the post, to be able to control its own effects, what's required in that process? What does a control feedback loop process look like for any alignment method to work in practice? If we're going to talk about the control problem, if we're going to talk about here's this AGI that we're introducing into the environment, and it's going to be changing over time as it learns new code and as the assembly processes that produce hardware can change, like this kind of assemblage, this AGI, how would you build in some kind of control method that would constrain or control its effects in line with internal reference values?
I'm noticing something I'm a little bit confused by. Specifically is in your use of the term the control problem. Stuart Russell uses it as in contrast to the alignment problem. The idea that if we try to control AI like our slaves, but it's more intelligent and more powerful than us, and we're making it do stuff it doesn't want to because we're using these various control mechanisms, that's obviously not going to hold up. So the solution is we deal with alignment, where we set its values because we're building it, and so that it doesn't want to do things that we don't want it to do. And that's like kind of control indirectly, but it's a thing that makes the first kind of control irrelevant. But it kind of sounds to me that you're not using control in that way of like forcing the AI to do something against its wishes. You're using it in a different way. Could you?
I think you're right. And I'm glad you're clarifying this. We're basically bringing up a bunch of vague concepts here. We're bringing up the concept of AGI. What does that even mean? Different people have different notions of AGI. Some people, it's like, hey, it's an oracle that can predict complicated dynamics in environments. I say, like, actually, I don't think that's a great way of thinking about this. I think we should think about what companies are pushing towards, which is basically autonomous machinery that like learn across various contexts and at the very least operate and maintain their own components, their own functional components, without needing to interact with humans to do that. So that's how I'm thinking about AGI. Another way of thinking about it is self-sufficient learning machinery.
And that seems pretty reasonable, I'll just say, because like one could argue whether something like ChatGPT or the large language models follow that pattern.
Right.
But as like Rob Miles observed once, a more agentic AI is useful. And so people are going to build that even if that's not what the current systems are like.
Right. This is what companies are pushing towards. Of course, you want to gradually automate the humans out of the loop in a way that the costs are lower and you can scale up things faster and more efficiently. So that's AGI, control, or the control problem. We can think about this in terms of the way you talked about it. Like Ailey Zakowski and the Miri team, they formalized that in terms of the shutdown problem. So like, hey, is there a way to have some metaphorical button you can press? And then the AGI is like, okay, you press this button, I'm now going to like shut down. At the very least, you would need to have that. From what I can tell, the Miri folks just weren't actually able to make enough traction on that problem. Like, how do you modify the internal utility function? A problem when you define a problem like this is that we need to consider whether it's comprehensive enough. Does it actually comprehensively cover the threats that dangerous technology like this can pose? So I'm talking about machinery that can fully kind of autonomously learn, operate, and maintain their own components. And I would say that's not a comprehensive enough scoping of the problem to cover all the things that could go wrong. And I think we need to expand that in a way that's less abstract, less relies on this abstraction of some utility function. And as long as you can kind of adjust the utility function, then the AGI will be fine to human beings. We need to think about actually what we're dealing with is all of these hardware components and code running on top that are connected in a way that together are able to sense and actuate across many contexts of the environment. Additionally, they're causing a lot of side effects just by continuing to operate within this environment and maintain their own components, which implies that they need to produce the parts again. If we're not including that in our notion of the control problem, we're forgetting a lot of stuff. We're saying all of those effects propagating through the environment. We can just assume that's noise and ignore it. And what I'm saying is like, no, this is crucial. This is part of the overarching problem we need to solve for in order to have any confidence that AGI can be controlled or can control itself sufficiently to stay safe.
Interesting bit of a frame shift here. When you're saying the control problem might not be solvable, I'm expecting to hear something along the lines of, hey, this idea of alignment, it's so fuzzy and uncertain. How do we define what human values are? Maybe there's some contradiction here in saying this, but where you actually seem to be going with is alignment isn't enough. That just focusing on this central conscious entity and what it wants, well, even if you were to somehow nail that down in some way and make that specific and get it to understand vague concepts like altruism or whatever else, just the fact that it's this big system of interacting components creates a problem regardless of what's happening in some kind of central cognition.
Yeah, that sounds fair. So you have this big machinery that's like big enough to be able to actually maintain and operate and reproduce their own components. That's just gonna cause a bunch of effects. Whenever we're just introducing technology in society, it can cause the unforeseeable destabilizing effects. We need to kind of take that into account. I think we need to be careful about not making the assumption like, oh, this assemblage is going to be omniscient. It's going to be godlike. And therefore, because it's really, really smart, it's going to just be able to control all of its own effects. It's going to be able to maintain a stable environment and humans will continue to live. It will be like that assumption of it being able to control all of the effects propagated through its interacting components is something that we actually need to inquire into in a way that's not vague and abstract, but it's actually thinking about this in terms of how people in the industry usually think about control, which is control theory, cybernetics, things like that. You've got some kind of control system that is sensing effects in the environment, that is modeling what's going on, that's simulating what could happen in the future, how these effects could propagate, what outcomes that could lead to, and then can evaluate conditional which actions would it lead to outcomes that is aligned with internal reference values. So, for example, in control theory, you have this notion of a set point. You've got some internal reference value that you're comparing the outside effects to make sure that the machinery is actually causing an environment is aligned or consistent with that internal reference value. We need to be able to think about it specifically enough like that, because if we think about it kind of vaguely, like, oh, it's intelligent, so it must be able to do all that, then we're actually not really thinking it through at all. We're just kind of making an assumption.
One analogy that's coming to mind here when you're talking about how much power some central thing that we're thinking about actually has on the ground with all the interacting components is like if I'm driving by my house and there's some section of the sidewalk where I can't park. And I think the reason is stupid. And then I say, damn you, Joe Biden, like well, it might not have had a direct influence on that particular decision that I didn't like. There's all these layers of bureaucracy of government from city, state, federal, all the way up. That's like a trivial example, but you could go further by having like certain sub-bureaucracies that actually go against whatever commands come down from the top. Is that kind of disconnect between different layers the kind of control that's we shouldn't assume and could cause problems?
Roughly, I think that's pointing at a crucial part here. I talked about there's like 5 steps that any control system that will be controlling AGI to make sure that the effects caused by the interacting components of AGI would be aligned with internal reference values. There are 5 steps, which basically just lines up with just traditional control theory. You need to sense the effects, you need to model the effects, simulate, and then like evaluate compared to some more abstract notions of like these are the values to align the system with, which I think is particularly what you're referring to here. Even if we assume that Joe Biden really cares about all humans out there and has found a way to stipulate that in terms of values and okay, based on these values, I want this entire political system to align. It doesn't necessarily it's going to work because the problem at that stage is that you've got this abstraction and you somehow need to make that concrete. You somehow need to concretize this very abstract notion of what this value is. If there's any kind of mismatch between the process that you're using to make comparisons with concrete effects against these alignable values, then it's quite possible you just end up with a leaky abstraction. You're not able to use that properly to make sure that the effects of the systems stay in line with that. We just see a bunch of destruction and as human beings like, something's gone wrong there. Can you even have a good control loop that's able to properly control all of these outside effects propagated externally? And if we notice that at each of these steps, from sensing to modeling to simulating to evaluating and comparing against alignment values to actually actuating or correcting effects, if we notice that each of these steps there are fundamental limits to controllability, if you multiply each state how much of a filter is happening there in terms of effects that will not be able to be controllable enough, you start to notice like actually there's a huge span of effects that would not be able to be properly controlled by the system.
I notice you mentioned fundamental limits here, because this seems pretty important, because I imagine the first sort of objection someone would bring up to an idea like this is, okay, this idea of some high abstraction not being able to control all the parts, that makes sense for people because we're very limited, but this AI could have unlimited compute power, be very smart, very, very well thought through. It could copy itself into various points.
Yes.
But that's basically just saying it will reach some kind of upper limit on what control is possible. And if that upper limit of how much control a system can have isn't enough, it doesn't really matter how smart it is.
That and the fact that if we're talking about more computation, we're immediately talking about more components doing the computation. So more transistors, you can make this as efficient as we can, but at some point you just end up with more components, more sensors and more actuators. By scaling up the processing capacity of this machinery, we're also scaling up the number of components doing that processing. And by scaling up the number of components doing that processing, if we look at any given component of the system, what degrees of freedom does that component have? How many different ways could it potentially interact as these components shift? How could these components interact with surrounding components and with environments? And you notice that there's some kind of exponential or even super exponential growth in the degrees of freedom of interaction across all of these components over time. We can't just look at that in isolation. We can't just say like, okay, we're just going to scale up the processing capacity of the system and not notice that with that, we're at the same time actually just scaling the degrees of freedom of interaction that the system overall has, the components with each other and with the larger environments.
I can see a couple of levels to this. If you look at computation on a very small level of just sending bits over the internet, there's a potential for errors, static mistakes, all kinds of things. There's control techniques for those. They're not
Yeah.
100% perfect, but they're usually good enough. But
Cyclical redundancy checks, things like that. Yeah.
But as things get more complicated, having redundancy checks or whatever else to minimize the error down to zero gets harder and harder. And so the amount of control gets less as things get bigger. And as you pointed out, adding more computation or intelligence to the system doesn't really get you out of that because, well, building that means adding more complexity, which is the source of the problem.
Yeah, so you're kind of expanding the combinatorial complexity of the system, like the number of ways that these components can be combined. But you can try and capture that with some kind of abstraction, but then the more you scale the system up, the more you have this kind of extended infrastructure that's involved in also like producing its own parts, the more these abstractions become really leaky. If you're going to try and think of an abstraction like, oh, how do we keep this AGI friendly or make sure it creates a healthy ecosystem or society? How do you connect that, or how do you find the correspondence between that and just like the sheer amount of effects that are propagating across this infrastructure and the entire environment as a result of introducing this machinery in the environment? So that kind of points back to what you were talking about, like, hey, if you just try and come up with some centralized ways of organizing the system based on some values that hopefully connect with what we humans want, even if that was possible, even if it was a way of defining those values in a way that everyone's like, oh yeah, great, that totally matches with my expression of preferences from all these different contexts over time. I totally agree with the science, like separate problem. We don't even have to get there yet. But even if you have that, there is this problem around, okay, how do you take those abstractions and then have some kind of control system that ensures that affects that this entire assemblage, this entire infrastructure of components, the effects they have and how those can feed back over time.
The core argument here is that even if we were to solve alignment, and that has all its challenges that a lot of my other guests have talked about, we still have the problem of how do we know that this holds up? Does the AI stay aligned to those original values that we somehow managed to get? I'd like to actually back up a little bit because we've kind of been jumping right into the weeds on some fairly complex and technical parts of this, and to just have a little bit of an illustration. And now I know illustrations have a problem in that they're not evidence. Someone could point out little flaws in it, but this is really just to understand the kind of worldview and danger scenario you're getting at. So I'm just going to propose a story, and I want to see how you fill this in. We've built a AI, and we've got the alignment thing down, and we've given it the task of reverse all the negative impacts that we've been having on the environment, solve global warming, fix the pollution in the ocean, and also make sure not to do this in a way that destroys human society, maintain a good balance. We've gotten all those values in there in a way that makes sense. 50 years later, the whole biosphere is destroyed. What happened?
Yeah, I think that's an excellent example also because there is talk, particularly from companies like, hey, well, AI is causing all of these pollution effects already, but somehow we can use this to solve climate change. So let's say that we have something that's actually AGI level. This is a general enough system that it's both able to optimize across all of these different internally simulated contexts, and also it has a general capacity to operate and maintain its own components across all these contexts of the environment. So great, we have that. Now let's try and solve climate change with it. Yeah, let me see. I think I'm going to jump over to the other side of the equation here. We just talked about fundamental controllability limits, which is basically saying, hey, we can't prevent this from just causing a bunch of destabilizing effects over time because we live in a very complex environment and there's lots of ways that things can break. And there's a bunch of ways that feedback loops can just chaotically destabilize through the machinery and just through things, just causing chaotic, destabilizing dynamics in the environment. So we have that part. But maybe someone might say like, maybe we're just really, really, really lucky. And this really complex life-supporting functioning that we're relying upon in terms of like how society and how the environment works, maybe somehow it won't actually destroy that in any way. Maybe there's a way that this could end up working and we could end up programming in some values around ensuring that the environment gets maintained well and society gets maintained well so that climate change is solved and all our societal problems are solved or something like that. Then we need to kind of jump over to the right side of the equation, which is around iterative effects that the system will have on the environment will actually gradually converge on human lethal conditions.
I want to make
And I
sure
can
I
get into that.
understand that first half of that before going on to the second half here. So these destabilizing side effects, this is like it's creating robots to troll through the oceans to pick up garbage or building carbon capture devices. But all of these things require resources. All of these things require creating stuff. There's a whole production pipeline needed for all of that. And all of the just lots of decisions that it's making could have all sorts of effects on the world. And it would have to factor all that stuff in making its decision to be doing all of these things. And so that the thing that maybe it's figured out, even though it's really hard, is some way of balancing everything. But then go on to this next part.
Yeah, let's say, like you said, we're just very, very lucky. The system did find some ways to function that happened to not cause any of those destabilizing dynamics that push the way society or environment functions outside any of the ranges that
Yeah, we've
would
just
cause us not
recognized
to
they're
thrive.
there.
Then there's this other problem if we go back to the definition of AGI that I proposed, which is, hey, there's this system that's not only general enough in terms of being able to internally simulate and optimize across many contexts, but also is able to operate autonomously and maintain and produce its own components. These are artificial components. They're different than the components of our body. They're standardized. They're based out of a different set of molecular materials.
It has to
It's
build machinery to do stuff.
yeah. Yeah, in order for it to continue to exist, otherwise it's not able to do the thing that you just outlined. It's like, hey, it can solve climate change and keep making sure that ecosystems work, et cetera, et cetera. It will need to somehow make sure that it continues to exist in some modified form over time. That means that you have this machinery. So you can almost see it as like a population of components that are connected in different ways that are interacting with each other in a way that they're able to maintain themselves, create the conditions to make sure that they continue to run, but also to produce any replacement parts, because parts erode over time. Once we start thinking about it that way, you have this machinery that's reproducing the parts for itself. So we're actually talking about something that looks awfully lot like a life form, or basically population. It's a little different than us humans. It's not a singular entity. It's a population of components that interact with each other to reproduce themselves. Thinking about it that way, we're actually talking about something that's kind of like artificial life.
I notice you use the word population, and that's interesting because it's easy to think about AI as like this giant brain in a box with these long tentacle arms reaching out into all its robots and controlling everything. But that's probably not very realistic. It might be more so like that than a human bureaucracy, but really it's probably going to be something like a kind of population where the parts have some degree of autonomy separate from whatever central thing is building them. And so population dynamics, not just psychology-like things would apply.
I don't have strong opinions in terms of how centralized the system would be. But one thing we can notice about how this system would work that would be different than human beings, there's ways that we're just limited. You and I are communicating right now over Zoom. We have to kind of move our mouths and vocal cords, and like there's just this way that we've got this really non-standardized way of trying to interact with each other, and somehow we're able to track each other over time. But there's just a lot of bandwidth bottlenecks. So that's, for example, one thing that you would not have a problem with this machinery. You would just be able to communicate bits at high fidelity across large distances using, I don't know, fiber optic cable or electromagnetic signals. And another limitation that the machinery would not have is it can expand itself. So you can have robots adding more parts to robots, or you can have a large language model where you just throw more compute at it and in that way expand it. You can replace components. So you can have a robot where like you replace some sensors with other sensors, or change some appendage with another appendage, add more appendages. These are all things we can't do as humans. We can't like expand our brain beyond the width of a skull. There is just this natural way that we tend to identify ourselves and other people as these kind of individual agents. But we can't actually make that assumption with something like AGI. And the reason being is that over time, all of these components can be connected up in different ways, can be expanded in different ways. If we talk about it as like, oh, it's an agent, or maybe it's like multiple agents, it doesn't actually quite work well, because the boundaries between these different clusters of functionality and directionality are actually quite fuzzy. They don't have to be stable over time. We could talk about things like selection for coherency, but overall, if we compare it to human beings, this is going to be a much less kind of stable entity, even though I hesitate to use that word, than the way we humans are, just because they're able to reconnect and expand in so many ways that human beings simply cannot.
So this is going to be a very alien kind of population. So we have to be very careful about what sort of assumptions we make about how it will work.
We need to be careful about not making these assumptions as like it's one macroscopic agent, like the way we think about ourselves. But we have an evolutionary bias towards thinking about each other that way.
Well, then, yeah, it'd be pretty important to notice those biases when they come up. Yeah. Anyway, though, you're starting to go on this story I'd presented of like, okay, so now we have not just one agent, but a whole collection of AIs in various forms. A population. What that means is a little different from a human population, but in any case, we have this, and it's pursuing its mission of fixing the environment, but doing so requires building replacement parts. I can already see a little bit of an issue since creating these mechanized things is the industrialized process that's destroying the environment in the first place.
Right.
Where does it really like go deeply wrong?
Yeah, so for the first reason, we should already be skeptical. But let's ignore that for now. Let's ignore the fact that corporations are scaling AI systems. And like that's basically the problem we've been dealing for a long time is corporations scaling resource-intensive machines in a way that contributes to climate change. But let's just go to this argument. Maybe we can build the ultimate machine, and this ultimate machine might be able to finally rectify everything because it's intelligent enough. Then we're dealing with additional problems that I call substrate needs convergence. You've got this population of components that are interacting with each other in a way that are at least able to maintain and reproduce their own components. And that's a setup for evolutionary selection. It's a setup for having these kind of changing population components gradually be evolutionary selected for things that are quite different than what we humans need. And what I mean by that is that when we're talking about these standardized hardware components, they're artificial. By definition, it's artificial general intelligence. They're based out of different molecular substrates than us humans. And also they're standardized in ways that humans just simply are not in terms of our components. And that's a crucial difference. We just need around room temperature to have all these chemical interactions happening in our bodies in order to operate and maintain these components in order to continue to survive. Whereas with silicon, you actually need very different kinds of conditions. For example, in order to produce silicon chips, you need above 1400 degrees Celsius to melt the silicon to overcome the binding energy of the outer electrons in order to put the silicon ingot into a silicon wafer. In terms of computation, once you introduce any metallic wirings and things like that, you want to reduce the temperature below zero. This is what happens with supercomputers. You reduce the temperature in order to reduce the electric resistance to make it compute better. So you can already notice that there's actually an extreme range of temperatures that the system can operate across and actually need in order to operate and to be produced. Unfortunately, under those conditions, we would just die.
The point you're bringing up here is that the ideal needs for computers and machinery is very different from the needs of biology. And so as a consequence of that, if machines were to just keep expanding and growing and covering all of the world, that's not something where we would just coexist as like another life form living side by side. It would destroy the environment and we wouldn't be able to live in the world anymore. But I want to continue on this thing of, if their goal is to improve the environment and they're only creating themselves for that end, what happens that makes it keep growing and in such a way that we can't live anymore? Is this an issue where you mentioned evolution at one point? Is this a case where, well, most of the robots are doing something that's helpful, but then one of the robots, because of the lack of perfect control, it gets some kind of mutation, as it were, that causes it to replicate itself a little bit more. And once you have some things helping themselves more, that has an advantage and that spreads and becomes the norm. Is that the kind of thing you're pointing towards?
Roughly. So something that we can notice with evolutionary selection, it tends to be hard to wrap our heads around, particularly with this alien machinery that we would have to talk about, this population of connected and nested artificial components. But what we know is that this is a changing population. If it's any kind of learning machinery, it will learn new code based on inputs, so code components will be changing. The hardware will probably shift in subtle but gradual ways because you just have all these assembly processes that can introduce tiny changes in terms of how this hardware is configured. If you have something like sensors or actuators, can subtly function differently as it gets reconfigured differently. And if it's functioning differently in interactions with surrounding components, it can cause all kinds of effects. And any time effects feed back in a way that happened to just allow those components to continue to exist, to be maintained in their existence, and or to be replicated, that gets selected for. That's basically the evolutionary selection that we're talking about.
Right. So just as a general idea of how evolution works, it's basically two parts working together, random mutation and natural selection. So there's little random variations occur in biology, that would be in DNA. But then if some are more advantageous in terms of replicating themselves than others, then you just see more of those. And because of the mutations, a future state that doesn't exist yet that is more stable, the population will tend to move in that direction. And so what you're seeing as applied here is that machines taking over would be advantageous in terms of like the ones that replicate more. Well, there'll be more of them, and that will occur because of the incomplete control and the little changes that occur in replacing the parts.
I can actually give a great analogy here, because I noticed like this is always somewhat vague and abstract to talk about at the beginning to create that overarching description. But here's an analogy that's actually based on real life biology. The toxoplasma parasite is this tiny packet of code, basically, with some surrounding protein that gets ingested by rats. So rats are just eating stuff in the environment, like there happen to be some of those kind of oocytes of that toxoplasma parasite around, they ingest it, and that parasite actually travels to the brain, starts spreading and travel to the brain of this rat. And then what it does, this is the interesting thing, there's this tiny packet of code, like this, let's call it almost like a component of itself. It's like this tiny set of components inside this rat's brain, and it's co-opting this much more intelligent, if we think about it that way, species to actually function very differently. So this rat has this existing navigation functionality. It's kind of navigating through this environment, through these spaces. And when it smells something like cat pee, it runs away, because obviously like it's evolutionary selected for it to not be eaten by cats. But what this parasite inside the brain of the rat does, it actually shifts that functionality. It repurposes the rat's navigation functionality to run towards the cat pee. So for some reason, the rat finds it appetizing now to go towards the cat pee. And then the cat eats the rat. So this is a way for the parasite to continue down its reproductive life cycle. What we notice about that example is that we've got these tiny components, these toxoplasma parasites, repurposing the functionality of a much bigger host. And something similar can happen in this AGI population. You can have all kinds of kind of mutated, changed components over time, co-opting existing surrounding functionality in a way that allows them to survive for longer and to reproduce at higher rates.
I see this point you're making right now is actually anticipating the first objection that would have come to the argument you made. Because the argument you were making a minute ago is actually pretty straightforward. If you compare one robot that's limiting itself to some mission and maybe even has to shut itself down once it's done its task versus another one that just keeps making copies of itself, it's pretty obvious which one evolution favors. But the place where someone might object is saying, well, there's this governing central AI that still has its mission intact. It's going to want to clamp down on that. It's going to see that single agent out there in the field. Maybe it doesn't notice it eventually, but the bigger of an impact it has, the more noticeable it becomes. And eventually it's going to send some police robots down and crush those. And
by the way, that's a great analogy. And notice that there's an assumption made there, which is that the agent that's doing the bad stuff is somehow separate from the host population. And that's not the case. What we're actually talking about is all the components that make up this body or this population. Those get changed over time and can actually co-opt the existing aggregate functionality in ways that allow them to survive and reproduce more. That's an important distinction to make. We're not looking at one agent, looking at a separate agent. No, in order for the self-sufficient machining to continue, it relies on these constituent components. It can't just identify them and destroy them. It would actually have to destroy itself in order to do that.
Will destroy a part of itself. I think it's important to keep in mind the lack of clear boundaries in terms of just thinking about it clearly. But one can imagine an analogy if there's a part of oneself, some aspect of one's personality that one doesn't really like, and then tries to act and suppress it. And the fact that there isn't a clear boundary doesn't mean that one part cannot push against another one.
Yeah, that's a good point.
But what you bring up with the toxoplasmic, that is an example of how the bigger thing doesn't always win. The smaller things can push back.
Yeah, and notice, by the way, that when humans who own quote unquote cats, when they actually ingest this toxoplasma parasite, it's also just that messes up a bunch of the way we function. So we also end up being more in traffic accidents, having fewer social relationships. There's a whole list of stuff that changes the way these parasites mess with us. So now you've got this even more generally intelligent agent. There's this relatively big part of the population that's infected by this parasite and doesn't notice it. And we haven't been able to solve it yet. But there's some ways that this analogy is incomplete or actually paints a more rosy picture than the substrate needs convergence argument I'm making. The key point is that we have something that is able to correct out things inside of cells that are harmful to us. It's called an immune system. Rats have it, people have it, and that is basically what allows us to survive against all of these incoming parasitic invaders. And that seems to work well enough for humans to have survived up to now. Unfortunately, the setup is different in terms of AGI. And the difference is that what we're talking about with AGI aren't necessarily parasitic variants. They're not necessarily parasites. It's more like there's a lot of ways that we humans are trying to constrain the reproductive fitness of this machinery. We're actually imposing ourselves or trying to extract stuff from this system in order to make it work for us. You can have a lot of different components getting involved within this machinery that would actually increase its reproductive fitness. Like you're going to have these mutualistic relationships between components in the system that allow them to survive and produce more. And it's very different than introducing something like a toxoplasma parasite in a human being or a rat, where it reduces the reproductive fitness of the host. And that's a key point here. Because if you have a parasite reducing the reproductive fitness of the host, then you have the host as an aggregate starting to kind of come up with ways to prevent that from happening. You've got an immune system detecting and correcting these incoming variants. You've got barriers like the blood testes and the blood follicles barrier kind of preventing this variant from kind of reproducing with future versions. Whereas with something like AGI, that's not necessarily the case. Like you can have these variants that support the reproduction of the system. So you actually have evolution in that way work completely against us human beings. Whatever kind of error detection and correction system we're introducing into AGI, evolution is not on our side. Whatever components they're able to find ways through their interactions, through their effects across that wider machinery to be able to circumvent that error detection and correction system, to be able to disable it in various ways or to co-opt or repurpose its functionality, they'll end up finding ways to do that.
The thing that comes to my mind is, say there's some modification to a cell that makes it cancerous. Now, I mean, you could say that is a beneficial error in the cell because now it's multiplying itself more and growing into this tumor rather than just being a single cell that would self-destruct at a certain point. But that doesn't prevent, like, yeah, I'm guessing why, knowing that the AI could reproduce more if it accepted some of these variations, would cause it to want that.
The key thing is just to notice that parasitic variants inside the population of components that would constitute a human being, that the larger population would be evolutionarily selected towards finding ways to remove those variants. To, for example, with the immune system to detect and correct those variants, or with the various barriers I mentioned, just to cause barriers preventing these variants from coming in. Whereas within a population of what constitutes AGI, that's not happening. Like that entire population, to the extent there's mutualistic relationships happening between various components, allowing them all to survive more and produce more, as overcoming some of the barriers we humans might have tried to set, or some of the kind of like, hey, don't expand too far, or like don't do this shitty thing to our environment to expand. Like all of those constraints we've tried to build into this machinery to stay safe to us, to the extent they're able to kind of circumvent that through these mutual interactions, that gets evolutionarily selected for in the system. So that evolutionarily antagonistic adversarial relationship that you have between a parasite and a much kind of larger kind of host population, as happens with human beings, for example, that's not quite the case with AGI.
I think I see what's throwing me off. I was thinking about it from the perspective of a singleton AI again. Like if some parasite starts working up the chain and trying to change its values, it doesn't really make sense in that particular context of why it would want to accept that. But if I instead think of this in terms of maybe a multipolar scenario where there's lots of different AIs and they're competing with each other, or even in a single case where it's some kind of hierarchy and you have something at low level acting on a more of a middle level, either that middle level AI or the one of many would then have a evolutionary advantage against all the other ones. And so these errors would move up the chain and then get stronger, in which case it eventually would be able to overthrow whatever top level thing is there.
Yeah, and notice that if this system wants something, if it has some kind of coherent, directed functionality towards certain outcomes, that's not going to be enough if it's not going to have the capacity to error detect and correct or control for these evolutionarily selected for variants. If it's just too limited to be able to do that, and I gave that example of like, hey, well, it seems like this sometimes happens in practice with toxoplasma parasites. It is not quite unreasonable if you think about it in terms of how biology works in real life. If this overarching system is too limited in terms of its ability or its capacity to error, detect, and correct out, then it doesn't really matter that there's some kind of want or kind of explicit mechanism that we kind of put in to try and make it be directed towards certain goals. Like over time, it will just gradually get taken over by these variants.
I can see two core variables here. One is how much control some centralized system that, again, we're assuming is aligned, that's its own challenge, is able to exert over the system as a whole. And then the second one would be how much control does it actually need? A lot of these examples you're giving and points you're bringing up are saying that the amount of control that it has is not as high as one might think. And the amount of control that it needs is actually pretty high because there's just some really thorny challenges that could get thrown at it.
That's a great description. Yeah, and one key thing to notice here is that we're not just talking about small mutations here and there and just evolution as a slow and local optimizer, but you have existing functionality that gets redirected and co-opted. Once we start looking at it that way, that it's not just like, oh, there's this practically omniscient kind of machinery, and then you've got these local mutations. All of that functionality inside that machinery can and would get repurposed, would get co-opted towards different ends, or the official term is acceptation. It would get accepted. There's really this question, is it possible to detect or model or simulate all of the different ways that functionality can subtly and gradually and increasingly get repurposed to create the conditions that allow them to survive and reproduce more?
One dynamic I'm thinking about is the relationship between positive and negative feedback loops. In the case of a positive feedback loop, you have some variant that's able to make itself stronger and stronger and divert more resources to itself and gains more and more influence that way. But on the other hand, you have a potential negative feedback loop in the form of the bigger of an issue something is, then the more noticeable it becomes. You seem to be arguing that the positive feedback loops are more significant.
That's one way of thinking about it. Basically, there are two feedback loops happening here. You've got the control feedback loops that are required for the system to stay alive. So that's a feedback loop essentially of detection and correction with a bunch of processing happening in between. And then you've got this other feedback loop that's happening across all of these distributed components, which is evolutionary selection. Whatever effects that these components happen to cause in interaction with each other that propagate across the environment, and feedback in terms of them happening to survive and replicate more, that gets selected for. So there's this way that feeds back over time. So there's that question whether the latter, the evolutionary selection, can be controlled by the former. Is the amount of control possible across that span of possible effects propagating across the environment over time? Is that extent of control sufficient in order to control for any of those increasing evolutionarily selected for effects? And I'm basically starting to sketch out why that is not the case.
So if I try to understand your full argument in broad strokes, first is that the needs of machinery and biology are very different from each other. So if you have something totally optimized for machines, then we're not living there anymore. Second, that there's a certain evolutionary pressure for the machinery to expand. Third, that this pressure to expand is greater than whatever control techniques are present. And so then you add all those together, you end up with this machinery that expands, fills the earth, and we can't live here anymore.
That's a great summary. Yes.
So I think those first two premises seem fairly clear. The third one, I think, is where most of the controversy is. In talking about the limitations of control, I think that gets to a lot of technical detail that's more than we can really cover here. So I'd like to move on by talking about how much control is needed. I'll point to Asimov's Foundation series from science fiction. It's premised on the idea that the future history of society is very predictable, and they can create mathematical models that can say what's going to happen, that this central empire is going to fall, and they'll make this new civilization that replaces it. But the rationale behind all of this is he points to things like the ideal gas law, which is that you can accurately predict the pressure at any point through a very simple equation, despite the fact that it's composed of all these molecules just bouncing around totally chaotically. None of that noise and detail matters because all of that chaos just averages out to some very comprehensible thing. And then it basically applies that to say that, well, yeah, individuals are chaotic, but they're kind of like the gas molecules bouncing around. And as you zoom out further and further into society, the more regular and predictable it becomes. And then you have these secret societies kind of just using these tiny little subtle nudges to control the course of history.
Right.
On the other hand, you have things like the three-body problem, which describes how, like, say, three or more stars would like orbit around each other. And in this case, that's a very chaotic system because, yeah, you could write a simulation of that like very easily, but a simulation is never going to be perfectly accurate. The whole idea is you leave out a lot of details, but those tiny details change the orbit a little bit. And when you have three things orbiting each other, those errors magnify. And very quickly, whatever model you come up with is maybe interesting in terms of learning about mechanics generally, but doesn't tell you anything about predicting actual paths. So the question then is the kind of control an AI would need more like the ideal gas law or more like the three-body problem, and why?
Yeah, I really like the analogy you sketch out there, the two different analogies. And I think that's a great way of thinking about it. If there is some kind of regularity, some macroscopic regularity that we can rely upon arising as a result of these interactions between all of these individual components, like what happens with the gas law, maybe it's enough to make broader assessments of the situation. Maybe that's enough in the case of AGI to say some broader things about how the entire system works in order to control its effects sufficiently to stay safe to humans. But the problem is if that's if we're basically talking about something like the three-body problem, which I'm arguing we're dealing with at scale, we've got this huge number of components, changing components. You've got code changing, you've got hardware changing, got them being connected in new and different ways. They're causing all of these feedback loops, all of these non-linear amplification of changes over time. Then we're dealing with a system that for the most part cannot be predicted. Then we're really dealing with a problem here. So yeah, I am arguing it's the second scenario. In some way, I feel like this should be intuitive to people. We're not dealing with just a simple complicated system where we can just say, oh yeah, if you just have these individual components interacting with each other, then oh great, we just have this nice linear system and that results. No, we're dealing with something that people call artificial general intelligence. So it would be surprising that if you have such a system that you can actually just predict things about what it will become over time. And it would be surprising if the machinery themselves can even predict it. Like, how can the system even predict what it would learn over time and how it will come to function differently depending on the code it learns over time? There's just limits in terms of the predictability here.
If I wanted to really dig into this and decide for myself what I thought about all these things, what are the topics that I should study?
A bunch of overarching topics that are useful to think about: signaling theory, complexity science, algorithmic complexity, things around how does chemistry work, some physics, control theory, how does control theory work, what would happen if you generalize control theory to something like AGI, or like the limitations in terms of what the system can control for. These are the kinds of things to look into that are basically prerequisites in order to really understand the underlying arguments.
if we're thinking about this in terms of how much control is available versus how much control is needed in order to stay consistent with the mission, those questions are the accumulation of a variety of different factors that are adding up. And if you want to be able to do that addition precisely, then you need to know what each of those parts are. And so things like control theory are all relevant to making this analysis on a precise level.
Right. So the arguments that I'm actually describing here, I originally took from an ex-Pentagon engineer. One thing that he's clarified to me is that you can actually think about this in terms of the way you just described. You can think about like, hey, here's a bunch of different parts we can add together, but there are actually ways to generalize this argument to be much more elegant. But I don't think that's a good way to start, because I think it's too abstract. So I think the way you're describing it is a good place to start. Like, think about how control theory would apply generalized to AGI. Think about how chaotic and kind of nonlinear kind of dynamics work. Think about how algorithmic complexity works. Like, can this internal algorithm make predictions? Can you have a simplified algorithm that makes predictions of some kind of larger, more complex algorithm? Is that possible? Under which conditions? Think about evolutionary selection. And try and kind of put those things together. I noticed during this conversation, unfortunately, that I wasn't able to pinpoint and connect these up as well as I wanted to. But it also just takes quite a lot of time. I mean, it basically took me a year to put these different pieces together. And I think people just need to do that work themselves. I can sketch out the overall arguments. I can point to some posts, like the summary post that you described. But this is work that you'll need to do yourself in order to be able to track the argument well enough, in order to kind of make judgments about it or kind of see whether it makes sense and whether the argument holds up or not.
Well, yeah, that makes sense for something as sweeping as a topic of what will be the impacts of a entity that's more intelligent than we are on the entire scope of the world. That's going to cover a really broad range. And if you're trying to get to it on a very precise level where every, logical question, there's like tests behind it and everything else, that's just going to be such a massive terrain. That's going to be a lot to understand. Going from a top-down approach makes sense to cover everything, but then you're necessarily sacrificing some detail when you go that route. And so that leads into the other way of thinking about this is just on a intuitive sort of level. What are the ways that I look at the world, and does this fit with things that are kind of known?
Other ways that you feel like it might not match up with your intuitions, where you feel like, actually, I think you raised some of these points already. Like, hey, a system that is super intelligent, that wants certain things, why would it allow these components interact with each other to subvert what it wants? I think that was one example that you gave of an intuition that I feel like more people would have in the community. Are there other things that you feel like?
I guess one that I suppose isn't really a counter argument is more just a interesting irony. So when I gave this dichotomy of ordered systems where all the details cancel out, so therefore you can know it with a fairly simple model, versus chaotic ones where you can't because the details explode, saying that this topic is more chaotic is the basis of this argument. However, the whole premise that we can know that AI will go in this general direction, even if we don't know the details, as opposed to just being, well, we have no idea what's going to happen with AI. It could go anyway. It could be great. It could be terrible. It could just be weird.
The sense of like, hey, many things are possible. Why would it go down this route? Like,
yeah, so you're saying it's going to go down this particular route, and which is implying that it's this ordered, understandable sort of thing, but because of chaos. And that's not a flaw, but that just seems a little, I'm just noticing that.
Yeah, so this comes back to the question of how much can we know about certain complex systems. So there's a way of knowing some things about certain complex systems where you can actually say, I don't know many of the interactions or like the things that would go inside it, but I know very broadly that it would tend to converge on this outcome, or it tends to get attracted towards this state. I don't know how it gets attracted, through which pathways, et cetera, across which states, but over time it gets attracted toward these states. And that's this distinction to make here. So on one hand, I'm saying, if you have all of those interacting artificial components changing over time that constitute AGI, you won't be able to make many accurate predictions about how those will come to function differently over time, and even the AGI would not be able to. At the same time, I'm saying like, but there is this thing called evolutionary selection that would tend to converge on very different conditions and contexts of the environment than we humans need to survive. So I'm basically making both arguments at the same time, and they work together. If we cannot guess or know what trajectories across which this AGI will change over time, but we can say that the set of conditions and contexts that it will converge on are disjunct with the set of conditions and contexts that we humans need to survive. It looks like AGI over the long term would converge on human lethal conditions and contexts of the environment.
The other intuition that creates uncertainty or skepticism for me is the application of evolution as an argument, restricting evolution to things that make the most copies of themselves. As an example, I'm pulling from the tendency of birth rates going down across the world.
Right.
One would think that, oh, whoever has the most kids, they're evolutionary selected for, so it should just keep pushing up and up and up, or certainly not go down. But the thing that misses is that the spread of memes or culture and ways of thinking is faster than replication. And so if the idea of have fewer kids is stronger as an idea than more, then that's more important than direct evolution.
One thing to consider here is that memes rely on physical human beings to spread. Similarly, code can only spread if it has some underlying substrate, in this case, hardware, across which it can spread in the case of AGI. So over time, you will have certain memes spread more across humans that are able to continue to survive and reproduce. So for example, if you have some religious community, let's say it's the Mormons, who say like, now actually we believe that having more kids is important for whatever religious reasons, then they'll have more kids. But the fact is that the memes are not disconnected from the underlying substrate in that way. If you have memes that allow people to have more kids and reproduce more over time across a large enough population, those memes will get selected for. You can definitely, within a short enough period, have a substantial portion of the population have some memes spread around where a substantial portion of the population are like, yeah, I can use a condom and I like to be able to have more sex without thinking about having kids. And I don't like the burden of having kids. And sure, that works. But there's two things basically that are going to happen here. Either somehow that meme is so effective that everyone stops having kids and the entire population dies out, or there's going to be some subpopulations over time where that they're going to have memes where that does actually support them to survive and reproduce and have more kids over time. And we can't make the assumption that there's a way within that population to just kind of instill some values or say something like, oh, this is what we want. And now we're just going to control that entire large evolutionary selection process. A similar argument I'm actually making with AGI is if you assume that the population continues to exist, if you assume that we're going to have AGI persisting, which if it doesn't persist, then it wasn't really useful, then we shouldn't really have built it anyway. If that's the case, then there are going to be subpopulations over time that are going to have evolutionary selection, either at the higher level code level or the substrate physical configurations level. Over time is going to select for whatever is needed for those subpopulations to continue to survive and reproduce more. Does that make sense?
I don't know if it addressed the core objection there. So you mentioned as a counter argument that this meme of having fewer kids is not universal. There are certain subpopulations that go the opposite route. The thing I would bring up there is there's going to be some difference in how effective atheists are good at converting Mormons versus Mormons are at converting atheists. And I don't know which direction that's going to go. It could go either way, but that seems like a more important factor in determining what the trajectory is, or if environmental conditions change what sort of meme is dominant. Like those kind of things would be more important than the actual birth rates in the various communities, just because they operate at a faster timescale. And the relevance to AI is kind of loose. It's basically just the idea that evolution has a lot more dimensions than might immediately meet the eye. And so the kind of stable state that we move towards isn't necessarily just what replicates itself the most. I haven't proposed here's this other thing that's more compelling. I would need to in order to actually make that a counter argument. But I'm just stating that as this is a thing that's making me feel less certain about this.
Yeah, and I think that's a good point. So there's basically this question around, is there a method or a way that can effectively cancel out this tendency? Atheists seem to be able to convert quite a lot of religious people. Is this something that can be generalized? And I mean, there is a way in which we can consider that if we human beings all actually need to be able to survive on the planet, that it's not too overpopulated for the planet to basically start disallowing our existence. Maybe there is a way based on shared evolutionarily evolved for needs and desires for people to coordinate around not having too many kids. Unfortunately, that argument would not apply for AGI. We can't say like, oh, maybe based on shared needs for survival, we can find a way to communicate enough and coordinate enough with the population of AGI components to not continue to spread. But yeah, I think this is a relevant line of inquiry.
One more intuition that's actually working in your favor is even before AI was this big thing, we already had this issue of in industry expanding and destroying more of the natural world in pursuit of this self-reinforcing profit motive. If we're having that big parts of the world becoming uninhabitable, even without AI driving it, then this idea of that existing trend accelerating seems plausible. And honestly, the whole techno-optimist idea of the only way we get out of this is through. When someone's making money from having people believe that this trend that's always been following is suddenly going to reverse at some point, I can see how that would be suspicious.
Yeah. This resonates. And notice that the current dynamics of corporations extracting profit with machinery and then reinvesting that and scaling up this resource intensive and polluting machinery more, that same dynamic actually tends to converge on something like AGI. When their models become more efficient at predicting data, engineers inside corporations tinkering with these models to make them more efficient, to automate more work, corporations competing on more general uses of these models to extract more profit. So you've got these different levels of selection that are pushing towards AGI as it stands right now. But we're already seeing that this is actually causing increasing harms. It is causing more laundering of our data. It is causing more workers to be exploited and sidelined. It is causing more unsafe uses of these systems as corporations just find more ways to use the systems, even if it's harmful and causes harmful side effects. And these corporations reinvesting in more machinery, more production of hardware is causing more pollution across the production and supply and operation chains of this hardware. We should really consider whether something that as a trend has tended to cause increasing harms over time, even though it has also produced some benefits, I will definitely admit that, whether that will lead us somewhere good and whether it's even good to aim to try and subtly shift that trajectory in a way that somehow then won't be harmful. Will that actually work out for all of us?
One more intuition I want to bring up, just for the sake of comprehensiveness, I wish was a straw man, but really isn't, is that standards of living have improved over the last 100 of years directly because of increasing mechanization and industrialization of the world. So as things have gotten more alien and strange and complicated, yeah, that's kind of scary in some ways. And yes, there are some side effects that are sad, but overall it's for the best. And so if we extend that trend out, then yes, maybe the world will be totally industrialized and mechanized, but that'll be good.
Yeah, so I agree that that's been happening at the same time, in the sense that we have been able to use machines for useful ends. We've been able to solve a bunch of problems with them. I really like my refrigerator. I definitely think refrigerators should exist. The question is whether what got us here will get us there, in the sense of, is the way that corporations have been expanding the use of machinery over time and finding more ways to automate more in our lives, is continuing that trend, is that going to be good for all of us? And the thing that I think we should take a look at is this sustainable? That's a term that gets thrown around a lot in climate circles, but I mean it in a literal way. It's great that we have cars and transport and things like that. But if your system relies on scaling up machinery more and more that require more and more energy and that cause more and more pollution, that's not sustainable. So something can be locally beneficial for humans, while at the same time, for example, already just causing the current ongoing sixth mass extinction with all surrounding species starting to die out from the way we've been taking over the environment with machines, logging trees, for example, for our ends. There's the sense in which the way that we're using machines is actually just causing the collapse of the ecosystem and the biosphere that we rely on, or even the society that we're relying on. If the way corporations are using machines is tearing up the fabric of a society, is causing a bunch of destabilizing effects over time, including things like, well, war. What got us here is just not going to get us there to the beautiful, healthy future that we're looking for. Because unfortunately, the trajectory we're on is then just not actually sustainable. Then we're actually making use of these machines for temporary local benefits, but in a way that's not going to allow the society and the ecosystem we rely on to be able to sustain that use of machinery over time.
The whole alignment problem and how difficult it is to catch up to where capabilities are is this overwhelming enough sort of thing. And what you're describing is even more pessimistic than that. This idea of pretty much no matter how it's built, this AI will lead to the destruction of life. If you're right, what should we do?
All right, so this is why I came up with that area for AI Safety Camp for do not build uncontrollable AI. We just talked about how there are already harms right now in terms of how corporations are scaling these AI models. And that's, well, bad for society and the environment. But there's also a way that we can actually start connecting with other communities that are noticing this. I was talking about data laundering. Creatives are actually just starting to notice how their copyright works, like laundered into these systems to create these large AI models. Privacy concerned people are concerned about how these corporations take the data to predict what they're going to do next. So these people are starting lawsuits. There's also bigger lawsuits like the New York Times lawsuits that you might have heard about recently. I'm working with creators to expand those efforts, to have more lawsuits, to have more ways to force these companies to stop doing web scale scraping of people's data. So that's one level. There's workers in tech and everywhere else. So you have, for example, the strikes that happened with the Writers Guild of America, where people said, like, no, we do not want AI to just be used by studios in a way that gets worked against the careful work we're trying to do here, where these studios are kind of starting to shoddily automate work. There's unions and other workers groups that are kind of starting to push back against the use of AI. There are whistleblowers. I know a bunch of whistleblower groups that are starting to look into what AI corporations are doing, where you actually have people from the military, for example, that have noticed the use of AI systems for directing drones and things like that. These people are starting to speak up. Then we can take a look at how these corporations are kind of finding more and more uses of these systems. And there too, we can actually act. The situation we're in feels a bit like the situation we were in the 1800s, where a lot of people were mixing up concoctions of elixirs to create medicines. You had all these competing with each other, finding new ways to I can sell it this way, I can sell this thing for this solution, and it solves all your problems. And at some point in, I think, the early 1900s, a bunch of experts came together and said, no, we should not allow this. We should actually regulate the use of these medicines and make sure that any medicine that gets produced goes through some careful pre-market approval process. The way the FDA works right now is that they require, including for medical software, they require the company to design for specific intended users, not just like everything, and evaluate for those users and have an independent auditor come around before they can market the product, let alone bring it to market. And that's, I think, what we need for AI. Right now, the state is that companies just say, we have general purpose AI, you can use it for everything. It's your responsibility if something goes wrong. We need to go back to having specialized AI models being used for specific intended users where they're carefully designed with those users in mind. So that's a way to restrict that. And then finally, with environmental harms, what we've noticed the uprise in climate groups protest against fossil fuel companies. There's been hundreds of litigation cases. The Way Sierra Club, for example, has been litigating against new coal power stations under the Trump administration. It was super effective, and they just found lots of nitpicks in terms of environmental regulations or how these coal power stations are supposed to work, and they just sued the heck out of these companies. The same can be done with data centers. So there are lots of ways we can actually act. And what I've noticed in the AI safety community, because we focus so much on this idea of like, hey, let's find some way to solve the alignment problem, that we haven't noticed all the different ways we can actually support and work in parallel with other communities to restrict corporate AI scaling. So this is a positive note. There's actually ways we can act if we start to notice that it seems that alignment problem is actually intractable, just based on like all the things we've been reading from different researchers. And then on top of that, the argument I just gave, fundamental controllability limits. This is also something that Professor Roman Yapolsky has published on, and substrate needs convergence. We can just say like, hey, actually, we don't have to stick our head in the sand and just wait to die if we find out that this problem is intractable after all. We can actually just stand proud and say, hey, we've looked into this over the last decades. We've really tried. And unfortunately, we've just uncovered more and more sub-problems that we've been unable to solve. And we noticed that we can't just chase after these AI companies and keep trying to interpret and align every new model they come up with and throw into society. This is a way that we can actually stand up with pride and take action and act with integrity to make sure that increasing harms are going to be stopped and that we prevent the worst kind of extinction risk happening, not just to humanity, but basically we're talking about total ecosystem destruction. Like, this is serious business. And I think we need to be able to be looking at this in an open enough way to look at like, hey, what are the different ways we could approach this? How can we stop these increasing harms from happening? How can we stop potential ecosystem-wide destruction?
Is it reasonable to expect to stop AI to the point of breaking this economic feedback loop that keeps pushing it forward?
Something to notice about this is that it's not, in principle, impossible to coordinate with other human beings to not do something that's harming all of us, that could start actually causing all of us to die out. We all share similar needs. We all need water. We all need food. We all need different particular living conditions. We can communicate. We're social beings. Having said that, I would say this is a hard problem. It is really hard to push back against these corporate dynamics gone too far. There's no reason to think that it's impossible to make this happen. It's impossible to say like, hey, certain technologies we're just not going to develop. There are cases of technologies not being developed in the past, like the use of gene technology to edit humans for the most part, except that one case in China for, I think, 40, 50 years has not happened because biologists came together and said, no, we're just not going to do that shit. And there are a bunch of other things like GMOs in Europe not doing that shit. There's no need to assume that we need to make progress in technology in this very particular direction towards AGI. There's a lot of things pushing in that direction, but we don't actually need to go down that trajectory. We can find more ways to use technologies that are more sustainable, that are more considerate and conscientious in terms of considering other humans out there, and where we can innovate in a way that's good for everyone. I think it would be bad if we just gave up and said like, oh, there's no way to make progress on that. If we can see that there are actual actions to take right now for which we can at least make local progress, if there are enough people coming in, noticing the harms and noticing that this could be an extinction risk, this would be an extinction level event if we allow things to continue in that direction, there are ways for people to come together and just start restrict this. And this, the assumption that AI corporations are just going to continue going is an assumption. If there are ways to restrict them legally, which has happened plenty in terms of climate, environmental pollution efforts in the past. If there are ways that we can just make sure that they don't profit of extractive and harmful uses, well, maybe they're just not going to be that competitive. Maybe traditional software is going to work better in lots of areas. Maybe we can actually just focus on innovating other parts of the economy. And this is something I want to give away here. I agree with you that this assumption of inevitable technological progress is a bit sketchy, in part because some of the people who are pushing that assumption are also the people who stand to profit off it in the short term.
So if someone hears all this and agrees with your overall notion that the best way forward is to stop development of AGI, whether they agree with you that it's certain to go down a particular bad path, or whether it's just too risky, or whether there's just too many side effects, what should people do?
I think it depends on your interests, your time, your willingness to take this seriously and do what you can. If you're in a alignment work, you can take some time to consider the arguments. There's the post that I guess you will link to in the YouTube description. So people can click on that, take a look, reach out to me if you want to clarify more. Unfortunately, I was only able to give quite an overarching and meandering description of the argument here. So that's one thing that can be used against the AI companies that say, oh, we're going to develop safe AGI, and can be kind of used to reduce some of the safety washing that's happening right now. On the other hand, if you have specific skills, for example, in machine learning, you can actually already start showing that existing models are already unsafe. So there is already work in terms of showing that these machine learning models can be made to be deceptive, and that deceptive functionality can actually be hidden. We can just have way more concrete machine learning demonstrations showing that even existing models should not be brought to market or marketed like they are currently. And that's a way to restrict ongoing development right now, rather than wait for people to agree that, like, oh yeah, maybe AGI could be dangerous. What about we just find ways to start restricting it right now? Because the way these machines are designed and used are already unsafe. If you have more of an activist bent, I will just point to Pause AI. I think they're doing some good work. I would also try and connect with other communities. One weakness I've noticed in the AI safety community is this tendency for people to think that we're the only ones that care about the extinction level harms of AI. And I mean, this is natural, but it basically means that a lot of people just feel helpless in the community because we're the only tiny little group and there's these big corporations we're getting up against. But there's many other communities out there that I've just mentioned. There's creative professionals, there's tech workers, there's other safety experts, there's environmentalists, and this group of people expand as these corporations start scaling up the uses of this machinery more in harmful ways. And by the way, I noticed in these other communities, for example, amongst creatives, people feel helpless there as well. I've noticed amongst AI ethics researchers that they feel like they're pushing against colonialism and capitalism and all the things that they notice is kind of bad about how these AI models are being developed. So every one of these communities I've talked with so far feel the same way. They feel helpless. They feel like they can't actually take on this problem by themselves. So what about we just find ways to work in parallel, find ways to support other communities, get them some funding. Many of these communities are actually cash trapped. Force AI is cash trapped. The creative professionals starting lawsuits are cash trapped. Let's get them some funding. That's maybe one thing we could do from this community, because we have some billionaires in this community that might be interested. Let's find ways to bridge to their perspectives in a way that doesn't assume that they need to understand what extinction risk is, or they need to assume some of the maybe too vague definitions of AGI and alignment that we've used in the past. Let's just act and act openly and do this with a seriousness of care for what we're trying to prevent from happening. And also with a seriousness around that whatever these accelerationists have been talking about is not inevitable. We can act. We can actually work towards better designed systems, specialized systems, and work towards building a society together that's just more healthy. So that's something that I just want to give away here. It does mean that you just need to open up to a lot of the messy social stuff happening right now. It doesn't mean that some of the conflicts you will notice, for example, between AI safety community and AI ethics researchers, that you'll need to spend time trying to understand where they're coming from. But if this problem is serious enough, let's take it seriously. Let's act and let's find ways to connect with other people and feel less lonely and feel less helpless in being able to do something about it.
I like that perspective about working across groups, because it's easy to think of about all of this as a purely technical problem. So that's often how it was originally framed, something that only a very specialized few can contribute towards. But if you think of this as fundamentally a coordination problem, where we need people that can work with people and bridge conflicts across groups or fundraise or just push for political activism, that becomes something that everyone can contribute to. People can vary in how much time or money they're able to spend, but at least in some degree, it's something where everyone can be involved, and as it should be, because this affects all of us.
Right. And also technical people. I think there are ways to shift in terms of your work right now where you can actually contribute to this as well. I mentioned that I think something like mechanistic interpretability is just not going to work in terms of being able to detect what's going on inside this machinery sufficiently enough to be controlling of AGI. But mechanistic interpretability can be used to show, like, hey, here's how these systems can function and malfunction if they're used in different contexts, or if you shift the inputs enough, if you don't constrain the inputs enough. And this is something we can do right now. I'm a little worried about how some of the AI safety work has been used by AI companies to justify that they're taking safety very seriously, where I think a lot of people in the alignment and safety community agree that no, that they're not taking it seriously enough. There's a concern that will just make it look like they're doing okay, and they can use it for their marketing and they can use it for HR recruitment to continue scaling. And I would like us to be prepared to push back more, to actually say, no, this is a problem that we really need to take seriously. And if you keep scaling up the combinatorial complexity and the outside connectivity of these systems, well, we're not going to be able to catch up with you. And by the way, it's not our responsibility to catch up with you. It's your responsibility to design current AI systems to not already be unsafe, to not already cause a bunch of harmful side effects, to not already cause a bunch of hallucinations, and to be misused so easily for disinformation and for other ends. So thinking about it from that perspective, we're holding these companies accountable for their actions. Working together on that is going to be tough. It's going to be tough to find funding if these AI companies start to not like that we're actually holding them accountable. But this is something where we can actually feel like we're doing something that feels right. We're not just going to go with the flow, hoping that we'll eventually find some magic alignment solution and then things will be okay. Or when we're not constraining our thinking to elegant ordered abstractions that where we feel comfortable, but we're willing to step outside our comfort zone and do what it takes to prevent these corporations from scaling further.
Cooperation between the social and the technical aspects of this problem, that goes both ways. It's not just that people focused on the human coordination aspect of it are just helping the alignment folks or pushing some agenda. It's also that people with a more technical bent are not necessarily just focused on creating some module that we wish that the AI companies created and say, here, use this last minute, but also being watchdogs who can cut through the PR spin and separate the reality from what's being told is in our best interests.
There's one other thing I'll add to that. That's a great paraphrase. If you're a technical alignment or safety researcher and your income and maybe your identity is dependent on working at these companies in a particular position or getting funding from certain people, think about how you can untie yourself from those perverse incentives. I think it's important to be able to think about this in a neutral enough way, in a way that you can attend to any concerns that you have about where corporations are going, and be open enough in your thinking where you're not constantly wondering about whether you're able to get enough of an income if you start pushing back. So think about like what your current situation is in terms of your work, in terms of the people you work with, and how do you gradually move things around in a way where you feel like you can speak up and you can point out problems with what these AI corporations are doing in a way that feels like you're acting with more care and with more integrity.
Is there anything else that is on your mind on this topic that you really want to talk about, but that I haven't asked about?
Take a look at the post. Feel free to reach out to me. You'll find my email address online. I'm happy to have discussions about this. It's good to recognize that we just all really care about getting this right. And we're all really noticing that the way AI corporations are scaling this shit is harmful. We have not been able to make enough traction on technical solution. So let's look around, let's talk with each other, let's find new ways to address the problems that we're noticing around each other to actually build traction together.
Thank you very much for your time.